Hello everyone. So today we have this hard problem. It's minimize deviation in array. Let's read the description. You are given an array nums of n positive integers like given here, and you can perform two types of operation on any element of the array, any number of times. Okay. If the element is even, divided by 2. Okay. We can divide even numbers by 2. If the element is odd, multiply it by 2. If it's odd, we can multiply by 2. The deviation of the array is the maximum difference between any two elements in the array. Maximum difference between any two elements of the array. Okay, so we have to find the difference between min and max of the array. Then we have to return the minimum deviation the array can have after performing some number of operations. Okay, so we have to minimize the difference between min and max element uh, by doing these operations that we can perform any number of times. Okay, let's look at the example 1, 2, 3, 4 and see what exactly we are supposed to do. So its deviation d is 4 minus 1, that is 3. So what we can do is we can divide this 4. It's an even, we can divide it by 2 and we will be left with 4, 1, 2, 3, 2. And the max here will be 3. So d will be 3 minus 1, that is 2. Then again, what we can do is we have um, min as 1. What we can do is we can multiply it by 2, and then we will have 2, 2, 3, 2. That is, we'll have 3 minus 2, and this will be 2. This is our maximum. Since we are trying to reduce the difference between max and min. We don't care about this 2 and this 2. Let's make it sorted, yeah, like this. So we cannot do any operation on odd number to bring it down, but we can take it up to like take it closer to our max number. So that's how it is. I think we will require a sorted array that we will have n log n, uh, um, and this will be done like every number of time. Let's try if we can do it. Nums is nums dot sort a b, and then a minus b. Okay, let's uh, create a function. What this will do is it will just simply sort whatever array we give it. Nums equals to nums dot nums equals to sort nums. And now what we have to do is we have this sorted. So if we look at the minimum number, we have to like increase it such that it becomes an even number, and then once it's even, then that means we we are nearest uh, to our high, since high can be even or an odd. Okay, Let's do a creation num start map and if n percent 2 equals to 0, we return n multiplied by 2, else return n. Okay, num equals to this. Other thing that we can do is we can like keep multiplying it by 2 until actually if we multiply an odd number then we get an even number. So 3 plus 3 is 6, 1 plus 1 is 2, 5 plus 5 is 10. So once multiplying it once will give it our number. And once we have it, then we sort it again. Actually, we don't have to sort it in the beginning. We can move our sort here. Once we have this, and then what we can do is we can we like suppose it was like this, and what we did is we made it 2 and we made it 6, and this sorting what will make it like this. So now what we have to do is we have to take this 6 and since it's the maximum and we have to take it bill down, so what we do is we take it, divide it by 2 and add it back to our array. So it will be 2, 2, 3, 6, and now our difference is 4 minus 2, that is 2. So now since it's 2, what we do is uh, we again take it and we divide it. It will become 2. So we keep doing this operation until we have either a odd number or the difference is I think just having an odd number will suffice. We cannot take it down further. So for this, let's have a while loop, while true, and then we let max is nums dot. At the end we have max and min is 0. Okay, now what we have to do is let deviation equals to infinity, and then deviation is math dot min of max minus min or this. Okay, so max percent 2 is not even, break if or. We have to return deviation. Deviation will be calculated like this. Hmm. Then We take max, divide by 2, and we add it to array, and then we sort the array. Let's see if it's working fine. 1 2 3 4. What we did is we did this. Now we have this array 2 2 8 3, and then we come inside. We find min, that is 2. We find max, that is 3. We find deviation, that is infinity or 1, and then deviation is 1. Then max percent 2 is, let's break it odd. So this is odd, and we break and we return deviation. Let's take another example, 4 1. This. So what we did is we multiplied 1 with 2, 5 with 10, 3 with 6, and then sorted it. So we have 2, 4, 6, 10, 20. Okay. And then what we did is we went inside. Min is 2, min is 2, max is 20. And then we find deviation, that is 18. Deviation is 18. And then max percent, it's not odd. So we continue and push max divided by 2, that is 20 divided by 2 is 10. So in the next step we have this, and then we sort it, then go back again, take 10 and find 8 deviation, and push 10 inside. It will go here, then again take this, will be 8, and we have another 5 here. This will be taken out, then we have deviation as 4, then we do it again, 6 is now 3, and then we have 5, that is 3. It should be 3. Yeah, right. Let's see if it works. It might give us a TLE since we are. Oh, it's a wrong answer. Let's try to see what is our nums in the end. Nums is 1 2 2. Deviation is math.min of deviation or max minus min. Okay, output is 2. How is it 2 if our deviation is 2 minus 1, that is 1? If you're taking minimum, it should be console.log. Let's run it again. 741 341 331 331. Deviation is 3, max is 3, min is 1. Initially max is 4. Not equals to 0. If it's odd, then we multiply it. Yeah, it worked. Uh, it might give us a TLE since we are doing a lot of sorting here. Maybe instead of this, we can use a priority queue max heap that will give us a max element in much less time. Yeah, I was right. It's a TLE. So min will be same. Uh, Initially min will be this, and then let's try to build a min priority queue with this. Let's sort it first, then build a priority. Max PQ equals to new. I will have to check the syntax for max priority queue. Okay, it's this new max priority queue. Okay, and then add everything to our queue. Now this will have max here, min is here. Now what we do is we find max from here, pq dot dq dot element, and then we find the difference and we push it to our priority queue. pq dot nq. Also we will have to see if min has been breached. Max dot min of min or max divided by 2, and yeah, let's see if we can um, run this. Max dot min time limit exceeded again. Yeah, right, I didn't remove this element. I don't have to sort the names array since we are using our priority queue now. Worked. Let's try to submit it again. Ah, nice. Finally, we were able to do it. And there are not many solutions here. Someone used an AVL tree for it. It's pretty long. Okay, thank you. That's all for today. We used heap. Let's add the tag, and that's all. Bye bye.